IGCSE Computer Science, Syllabus Statement 1.1.3d, Identify and Describe Methods of Error Detection and Correction. So, this video, as this says right here, we're going to be focusing on parity checking. And this is because, this video, that is, the entire statement is pretty long, all due to parity checking, which is the longest aspect of it. So I decided to put just this in one video, and the rest in another, which is going to be the next one. So, let's get started. So a parity check is a method of error detection and data transmission from one device or medium to another. For example, if a byte of data is transmitted, it would have a parity bit allocated to it before. Systems which use odd parity have an odd number of 1 bits. Systems which use even parity have an even number of 1 bits. To get a better idea, take this for example. Say you want to submit just this part, ignoring the red thing right here. So if even parity was being used to transmit this, the parity bit would have to be 0, as there's an even number of 1 bits already. So you can count them, 1, 2, 3, 4. So that's 4 1 bits, and 4 is an even number. So the parity bit here would be 0. If odd parity was being used, parity bit would have to be 1, as there is an even number of 1 bits. So 1, 2, 3, 4 plus 1 makes 5. And 5 is an odd number. And same with this and this. So hopefully you get the idea. Before data is transmitted, the sender and receiver of the data agrees on which type of parity to use. If a byte was sent from the sender to the receiver, and they both agreed on even parity, an error would be flagged if the byte had an odd number of 1 bits. This error is detected by the receiver checking the parity agreed and the number of 1 bits, including the parity bit, in the byte sent. So, for example, if you were to send this is the parity bit of course, and the receiver receives this, well, this is 4 1 bits, and this is 3, so clearly an error has occurred in the transmission of this. So, the question might be in the exam, even parity is used. You'll always know what parity is being used, otherwise how can you do the question? Which of these bytes have been transmitted correctly? So, this, and this. So, let's count the number of bits here. And remember that even parity is being used. So 1, 2, 3. So that's 3. So it must be incorrect. 1, 2, 3, 4. So that must be correct. 1, 2, 3, 4, 5, 6. That's correct. 1, 2, 3, 4, 5. So that must be wrong. Or incorrect. Yeah, incorrectly transmitted. And 1, 2, 3, 4, 5, 6. That's correct. And of course, this is 5. And that's an odd number, and this is 3, and that's an odd number, and the rest are even. But the receiver doesn't know which of the bits has been transmitted incorrectly. One way around this problem is sending a parity byte as well, and using this method, blocks of data can be sent. So odd parity is used here. So a parity byte is sent along with this byte being sent, and of course this is the parity bit of this byte, and I've sort of made the parity byte stand out. So this was sent, but this was received. So where was the error? So what we do is let's look at the sent one just to get a better idea. So the parity byte is calculated by checking the parity of the vertical it's basically a vertical check. Because the parity bit is calculated horizontally, so 1, 2, 3, 4, and if odd parity is being used, this would have to be 1 to make 5. But this is vertical, so basically sort of counts the, each bit column. So, for example, odd parity is being used here, so if there was 1 here, this could be 0. If there was 0 here, this would have to be 1. And so on, to get, odd parity, or an odd number of 1 bits. So if this was received, where would the error be? So what we do is count the horizontal first, or vertical, doesn't really matter. So 1, 2, 3, 4. So this row clearly has an error because that's the only thing being sent. And we check the horizontal or vertical, vertical rows, or the columns. Yeah, I'm screwing up. The columns, we count the number of 1 bits in the columns. So this would be 1, 1, 1, 1. And now here we have 0 and 0. 0 here is classified as an even number, so there's the error right here. So there's an error with that bit. So let's look at an actual block to help you get the idea of how this works. So even parity is used, and this is sent. So again, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, and that looks all that looks all good. So let's count the vertical. 1, 2, 1, 2, 1, 2, 1, 2, 3, 4. So that looks all good if we count them up. So again, a parity byte is calculated using the columns of all the bytes sent. So since there's 1 here and even parity is being used, this would have to be 1. But this is received. So how do we find that? The error. So we count this again, and remember that even parity is being used. 1, 2, 3, 4, 5, 6. That looks good. 1, 2, 3. Here we are. With byte 2. That's where the error seems to be. So let's check where it is vertically. So 1, 2. That looks good. 1, 2, 1, 2, 1, 2, 3. Here we are again. So this must be the bit that's been transmitted incorrectly. So here's a question. Odd parity is used. Locate the incorrectly transmitted bit. So again, we count the rows. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3. And we don't include the parity byte because this is, remember, calculated from the vertical counts, so we don't have to count that. So clearly 6 is the only even number here, so it must be in byte 2. So let's find out which bit it is. So we count that should get 5. 1, 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3, 4, 5. 1, 2. Here we are, the 2. And this is 1. So it must be here. So this is the only even number here. So that must have been transmitted incorrectly. But what if an even number of bits have been incorrectly transmitted? Well, then there's no way of the receiver knowing, honestly. So, for example, take the byte 01010001, which has 3 1 bits. And that could be transmitted as 0000001, which is 1 1 bit, 2 bits changed. So, we know that, looking at this, that this is incorrect. This has been incorrectly transmitted. But how can the receiver know? Because there's 1, 2, 3, 3 1 bits, and 1 1 bit. So both the original and the altered bytes pass the odd parity check, because they have odd, they both have an odd number of 1 bits. So this is a limitation of parity checking, and that's why we need to look at other methods, which we'll look at in the next video. So for this question, there is really no way of telling. But don't say that in the exam if they ask you to find out which have been transmitted correctly, because you might not get the mark. But I'm sure they'll, they did, in the 2015 paper, they did actually ask why, what a limitation of using parity checks Well, so, yeah, that's it for this video.